That's the whole idiot. There you go, I'm doing a job then. So, direct variation, we've got this linear function. However, we can also say, what if P varies as the square of Q? Okay, so this, so again, okay, now what this means is, this time P varies directly, so we're still dealing with direct variation, which means as one increases, so does the other. But this time it's Q squared. Okay, so we could still write P equals K times Q squared. Alright? That makes sense?
Yeah.
We could say P varies as the square root of V. So that would be P varies as the square root of V, which would mean P equals K times the square root of V. So the whole process doesn't really change, but you have to take note of that extra piece of information. Okay? And that extra piece of information is that square or the square root, or it could be cubed or so. Yes?
Okay, would you be able to say P varies as the square x of Q? It's like putting the exponent as
I don't get what the square x. What do you mean by
so basically, like P is directly proportional to Q to the power of x. Would that
yeah, no, that yes we could, because that is showing a relationship. That's showing an exponential relationship, isn't it? Yeah. Yeah.
So for P varies to the square root of V, if V was 25%, P would be 5, right?
Well, it depends, because you've got the K, haven't we? So again, we have information. It's like we could say when P equals 36, V equals
3, and then K can
3?
equal 4.
Well, would it though? This might be a really horrible one that we've just chosen. So what would K be? So we would then say 36 is equal to K
Oh, sorry.
times the square root of 3.
V would be 9.
It
If
wouldn't, would
V
it?
was 9, then K would be 4.
No, it wouldn't. What we should
If
do
P was 27,
to make this easier,
Well,
let's
V
do
was-
it like this.
Oh, V's 81, K's 4.
Let's do P is 3 and V is 36.
Oh yeah,
Right.
that's easy.
That way is a bit better. It's easier to work out. So what would we do then? We'd be working out our,
6, so K would be.
so that would mean 3 is 6K, which makes K
0.5.
a half.
Yeah.
Okay. So we would be saying P is a half of root V.
Yeah.
Right. So the same way we did it with a linear, we have to use the information. But what people tend to do is forget to do the root or forget to do the square. So for instance, up here on this one, I could add the information. So when P is 2, Q equals, sorry, I'm going to the other way this time, aren't I? So let's do 24 and what should I do? 3. Pick some nasty numbers. But it still works. So what do we do again? Using this one we would say 24 equals
K
times 9, because 3 squared is 9. Okay, so therefore K is 24 over 9. So what does 24 over 9 simplify to?
24 over 9.
8/3.
24 divided by 9 is 8 divided by 3. Good. So we can actually do k in simplest terms as 8 divided by 3. So over here I can now write p is 8q squared over 3. And that's my equation linking the two variables. Okay? So we do the same process.
Would it be 8q squared all over 3?
Yes. Alright. So we've got the same process. It can be squared, it can be cubed, it can be cube root, it can, you know, different roots if we like. You might want to write some notes down. Okay, so just sat there with your books closed. Alright. This isn't going in OneNote, by the way. It's been bugging, so I'm not there in the notes at the moment. I'm going to try and go back to it. But this is recording. Yes. Maybe you'll want to read it. But so that's the idea. So we've got same kind of idea as the linear stuff. But do you notice how, well, what kind of function do I have here then, now?
Exponential,
No,
linear,
no.
distributed.
Quadratic.
Quadratic, thank you, yeah. Alright, so that's a quadratic function, isn't it? So you are used to seeing y equals 3x squared, for instance. So that is a relationship between x and y, where the constant of proportionality links the two in a quadratic relationship. And what will the graph look like? What will the relationship between y and x look like?
Parabola.
A parabola, won't it? Yeah. So the ones you were doing this morning, just now, were straight lines because they were linear. This is a quadratic, so you might kind of only do half of it, you might do both, but you've got your. What would the graph of this relationship look like?
It would not have a parabola, but it would have.
It would be
parabola on the
reflected
side.
across the line
Exactly.
y equals x.
Kind of that, yeah? Remember we talked about
It'd
that?
still be a parabola.
Yeah, we would consider both sides of it, wouldn't we? Right? But you get the idea, yeah? So you've been doing all these proportional relationships for years, but if it's a linear relationship, it's a quadratic relationship, if it's a root relationship, so you can just, you're expressing the things you've done for years just in a slightly different way, that's all. Yes?
What is like the official definition of an equation by all mathematicians, like that's agreed on by all mathematicians?
An equation.
Yes, like the official definition, word for word verbatim.
What language?
In
I
English.
can only do it in 5.
Well, in English, please.
An equation is where you have something equals something else. That's why it's an equation. Zoe, stop chopping things off your book. Zoe, open your book and start writing.
I need to
Didn't. An equation is just when we have to use an equal sign to say one side equals another.
Okay.
Often what we would say is an equation has a variable
Mm.
equals something, and that could be an actual value, or it could be another expression, or yeah. Nicholas, you're
Do you have bladder?
just after lunch,
TI.
straight after lunch. Yes, Nicholas, but the video's going to carry on. We're going to carry on teaching. You go. All right, so we've got these relations. You've seen them before. So I think, like you were asking, you've also seen the y equals k, let's say, a to the x ones, yeah? That is an
Oh yeah.
exponential.
Oh.
But we've got an exponential, what's to say, relationship there.
So when the exponent is a variable, it's exponential.
Yeah,
But when the exponent is like
so I'll change that
is a known,
to
it's
something.
quadratic, right?
But you'll notice that it's a relationship based on a base of 2, but we've still got this constant of proportionality. So we're saying y is linked to 2 to the power of whatever x is by this constant, by the k value, whether that's a 2 or a
And then-
half or an eta.
And then
Yeah.
actually solve the that you need to find out. Okay.
Yeah, exactly. We wanted to find the equation that linked those two things. That's what we would do. Okay. Right, so you can probably apply that without having too much more on this. But what I want to move on with then is inverse variation. Okay. So we say variables that have an inverse relationship. So we could say m. Sorry. So m varies inversely as n, for instance. So what does this mean?
Does that mean that
Go on, keep reading.
That's when the n is multiplied by a number, n is divided by the same number.
Exactly.
Which is an inverse operation.
So let me just add up to here. So the direct variation stuff, we can kind of simplify it to when one increases, so will the other one. If P decreases, so will Q. Alright? However, when we've got inverse relationship, we have a different setup, which is we say n varies as 1 over n. So that's the inverse relationship. So that, if we do that, and you can see why, if n increases, alright, 1 over n will actually decrease. Because n will get bigger, alright, but 1 over n will become smaller. Alright? And in the same way, if n decreases, 1 over n increases. Alright? And we would still do the same thing, in that what does the fishy symbol get replaced by?
Is equal to k
Yeah.
divided by.
So m equals k times 1 over n. So we still have that equals k thing there. Right? But we do write it in a slightly different way. So what would this get written like instead?
it would be written as m equals k1 over n?
K
But without the
K
x.
one.
K divided by n.
K divided by n. That's what we have it like that.
Oh, yeah.
K times 1 is k.
Mm.
Yeah. So, alright, so we have the same idea. And we can link the two. So we can say when m equals 3, n equals 2. Let's find k. What would we do? So 3 equals k divided by 2, which is, k would therefore be
6.
6. So we would then say m is equal to 6 over n. So that's our relationship. Okay. And the same things can apply with the squares and square roots. Alright? So we can say, what if I say a is inversely proportional to the square of b. How would we write that?
A fishy symbol would be.
Whatever it is.
1 over b squared this time.
Oh, square.
The square of b. Yeah. So then I would rewrite that as the equation would be A equals,
K over B squared.
yeah. And again, I'd have to give you some information, that two values, so you can work out K.
So,
So if I said to you, give me two that are going to make K nice, you come up with one off the top of your head and stuff. What would you choose for A and B if you were teaching someone this?
10 and 5.
10 and 5, you think?
Or 4 and 2.
And
Or 5 and 5.
Well, let's check 10 and 25, 10 and 5. 10 and 25. Okay, let's just check then. So that would mean that 10 equals K over
Oh no.
25. Oh, lovely,
It's
thanks
like-
for that.
So 125. No.
10 is K over 25 squared.
125,000.
Eh?
125,000.
125,000.
No. It's 125 on the bottom. But it's
Oh,
no 100.
25
1,000.
times
sorry.
25 is not 125.
I don't know. I don't know what it is.
300.
400. 425.
Wait, what, wouldn't it just be
It's
25?
425.
25 squared.
B is 5.
It's 425.
No, no, it says B 25.
Wait, no,
Oh, I
it's
said
not
25.
You said 10 and 5. Okay, alright. That's different.
That means K is 250, right?
So we've got 10 and 5 squared, which makes K 25, which makes K 250. So then I can write A is 250 divided by B squared. So that gives me my equation thing. So that's it, right? Again, you can see from this equation that if I increase A,
B decreases.
this side will
Decrease.
decrease. Okay? Which is what we want for inversely proportional. Some people make a mistake and think direct variation is when one increases, so does the other one. So they both increase. Therefore, inverse is when one decreases, the other one decreases. But it's not increasing or decreasing, it's when the same effect happens. So either if they both increase or both decrease, that's direct variation. When one increases, the other decreases, or vice versa, then we've got some inverse variation. Now, do you know what that graph would look like?
Ooh.
So I'm going to take you back up to this one because it's simpler. Any ideas?
Maybe quadratic.
Well, it's not quadratic because otherwise I'd have a direct relationship.
I don't remember saying there's a 1 over x to the 2.
Yeah, exactly. A reciprocal function. One that looks like that, yeah?
That'd be boring.
Remember that? And something of the form when you have an inverse relationship with squared. Anyone? I think you have seen it in a question I've given you, but if you don't remember, could be something like.
Oh, would just be like, what?
Oh, I'm just reading
All I see is one path that splits into two.
So that has now two asymptotes.
It's two reciprocal lines, kind of.
Alright, but that might be one for you to look up. Right? But that's where inverse proportion gets a little bit more complex in terms of an actual function. Right, so I have some past paper questions to give you now, so you should have enough information at this stage